Albert Einstein, a name that has become synonymous with brilliance, innovation, and groundbreaking discoveries. His theories didn't just change the way we understand the universe. They shattered the very foundations of physics and opened up new realms of possibility. But what are the predictions and ideas that made Einstein the genius we celebrate today? In this video, we're diving deep into the top 5 predictions of Albert Einstein that forever altered the course of science. Prepare to be amazed as we explore how these mind-boggling ideas turned out to be true, revolutionizing everything we thought we knew. And trust me, don't skip the video because at the end, there's a surprise you won't want to miss. Let's start with one of the most profound and transformative ideas in the history of science, Einstein's theory of general relativity, introduced in 1915. Before Einstein, scientists believed that gravity was just a force between objects. But Einstein took a giant leap forward by suggesting that gravity isn't just a force, it's the warping of spacetime itself, caused by the mass of objects. Imagine a trampoline. If you place a heavy ball in the center, the fabric bends around it, right? Well, that's how mass bends the fabric of spacetime. This theory completely changed the way we perceive space and time. But it doesn't stop there. Einstein predicted that massive objects like stars and planets would not just create a pulling force, they would actually create ripples in spacetime, which we now know as gravitational waves. For nearly 100 years, these waves were just a theory. Then, in 2015, scientists made history by detecting gravitational waves from the collision of two black holes. This confirmed that Einstein's century-old prediction was not only right, but also set the stage for new discoveries in astrophysics. Next, let's talk about one of the most mysterious and fascinating objects in the universe, black holes. The idea of black holes was actually hinted at by Einstein's theory of general relativity. According to his equations, when a massive star runs out of fuel and collapses, it can form a singularity, a point in space where the gravitational pull is so strong that not even light can escape. Einstein, however, was initially skeptical about the physical existence of black holes. He dismissed them as something purely mathematical. But as the years went by, scientists and astronomers began to see evidence of their existence. In 2019, the world witnessed a historic moment. The first ever image of a black hole was captured by the Event Horizon Telescope. This black hole, located in the center of the galaxy M87, is 6.5 billion times the mass of our Sun. Black holes are now a key feature of modern astrophysics, and Einstein's theory paved the way for their discovery. Einstein's theories didn't just challenge our understanding of gravity, they also revolutionized our view of the entire universe. Let's talk about the expanding universe. Before Einstein, many scientists believed that the universe was static, unchanging. But Einstein's equations predicted that the universe should either be expanding or contracting. To keep things stable, he introduced what he called the cosmological constant, a term in his equations that balanced the forces of gravity and expansion. However, when astronomer Edwin Hubble discovered in 1929 that galaxies are moving away from each other, Einstein had a revelation: the universe was indeed expanding, just as his equations had predicted. Einstein later referred to the cosmological constant as his biggest blunder. But in hindsight, this so-called blunder led to the discovery of an expanding universe and ultimately the foundation for the Big Bang Theory, the idea that the universe began from a singular point and has been expanding ever since. While Einstein's contributions to relativity are often the focus of his legacy, he also made major breakthroughs in the realm of quantum physics. In 1905, during what is now known as his Annus Mirabilis miracle year, Einstein proposed the idea that light behaves not just as a wave, but also as a particle, a concept we now call photons. This radical idea was part of his explanation of the photoelectric effect, where light shining on a metal surface can release electrons. Einstein's work showed that the energy of light depends on its frequency, not its intensity. This idea was a game changer. It led to the birth of quantum mechanics, a field that today governs the behavior of subatomic particles. For his work on the photoelectric effect, Einstein was awarded the Nobel Prize in Physics in 1921. His research laid the groundwork for technologies like lasers, solar cells, and quantum computing, which are still transforming our world today. Now, let's explore one of the most mind-bending consequences of Einstein's special theory of relativity: time dilation. Imagine this: you're on a spaceship traveling at nearly the speed of light, and you're looking at a clock on Earth. You would see time moving slower for you compared to the clock on Earth. This phenomenon is known as time dilation, and it's a direct result of the fact that as objects approach the speed of light, time itself begins to stretch out. It may sound like science fiction, but Einstein's equations show that it's a fundamental truth of the universe. Over the years, scientists have tested this by placing precise atomic clocks on airplanes and satellites. The results: time really does pass differently for objects moving at high speeds. This has even been factored into GPS technology, ensuring that satellites orbiting Earth stay synchronized with the time on the ground. Without Einstein's theory of relativity, our navigation systems would be much less accurate. From bending spacetime to unlocking the mysteries of light and time, Albert Einstein's predictions have reshaped our understanding of the universe in ways we couldn't have imagined. His revolutionary theories have not only withstood the test of time, but have also paved the way for many of the scientific and technological advancements we rely on today. But here's the big surprise: these theories are just the beginning. The universe still holds many more mysteries, and Einstein's work has only scratched the surface. So, what's next? What groundbreaking discoveries are waiting to be uncovered? Don't forget to drop your thoughts in the comments below. And as promised, stay tuned, because in our next video we'll explore something that could completely change the way we understand time itself. You won't want to miss it.